Welcome to the beautiful state of Hawaii. Out of respect for the heritage of these islands, every effort has been made to honor the Hawaiian language and culture. We apologize for any unintentional mispronunciations. For centuries, the story of this land has been told through hula, a dance that mirrors the rising mountain, the falling rain, and the calling ocean. It is a relationship with nature that goes far deeper than the surface. At 13,796 feet above sea level, the air is thin and the silence is absolute. This is the summit of Mauna Kea, the tallest mountain in the world, if measured from its base. But the vast majority of this mountain remains invisible. It doesn't end at the shoreline. It plunges through 3 miles of Pacific blue to the seafloor below. In a 90-minute drive, one can travel from a frozen alpine desert all the way down to here. 78 degrees, clear as glass, a completely different world from where we started this morning. At night, the mountain reveals its true scale. 40 feet below the surface, the darkness comes alive. These are the night feeders of Kona, manta rays gliding through beams of light. To float here is to realize that the reef isn't just a seafloor, it's a ledge on an 18,000-foot mountain. Hawaii is the most vertical place on the planet. And everything here, the cold at the summit, the warmth at the surface, and the darkness miles below, exists on the same engine. And it's the engine that may hold the key to the island's future. Here's what you notice when you look at Hawaii from space. 2,500 miles from the nearest continent, the most isolated population center on Earth. 1.4 million people, in the middle of the Pacific Ocean. For most of modern history, that isolation was expensive. There's no oil under these volcanic islands. No coal. No natural gas. Which meant by the 1970s, Hawaii was importing 85% of its energy from thousands of miles away. But here's where the story gets interesting. Because while the rest of the world saw Hawaii's isolation as a weakness, engineers here started seeing it differently. They started asking, what if the very thing isolating us is actually our greatest resource? Because while the rest of the world was building power plants that needed fuel, or solar farms that needed sun, or wind turbines that needed breeze, Hawaii was sitting on top of a machine that never stops running. The surface, 78 degrees. 3,000 feet down, 39 degrees. That 39-degree difference? That's not just temperature. That's raw thermodynamic potential. And it's there, every single day, every single night. But this idea, using the ocean's natural temperature layers to generate power, wasn't actually new. In fact, someone had already proven it worked. In 1930. A French engineer named Georges Claude, the same man who invented neon lighting, is standing on a platform watching water flow through pipes from 2,000 feet below the surface of the Caribbean Sea. His idea was simple. Use the temperature difference between warm surface water and cold deep water to drive a heat engine. Generate electricity. No fuel. No smoke. Just physics. And on that day in 1930, it worked. Just 22 kilowatts. Not enough to power a city, but enough to prove the concept was real. Georges Claude had just demonstrated that the ocean itself, just by existing, just by having depth, could generate power. But then the world forgot about it. Because energy was very cheap and abundant in the 1930s. Oil was flooding the global market. Not literally flooding. Claude's ocean thermal plant was destroyed by storms. The technology was expensive. The pumps consumed almost as much energy as the plant generated. And with oil selling for pennies per barrel, why bother fixing it? For 40 years, the ocean kept it secret. The temperature gradient, that endless, renewable engine, just kept running. Waiting. And then, 1973, the oil crisis. Prices quadrupled overnight. Energy, for the first time in a generation, became a national security problem. And nowhere felt it harder than Hawaii. And that's when someone found it. A dusty research paper from 1930. It described a machine that generated electricity using nothing but the temperature difference in ocean water. And it had worked. 1974. The state of Hawaii establishes the Natural Energy Laboratory, NELHA, on the Kona coast. Their mission, resurrect OTC. Update Claude's technology with modern materials, modern pumps, modern engineering, and prove it could work, not just as a curiosity, but as a real power source for an island that desperately needed one. They started small. Test systems, pilot plants, learning what Claude had learned 40 years earlier, but this time with better tools, better plastics that could handle the pressure at depth, more efficient pumps that didn't consume all the power they were generating, heat exchangers designed for decades of exposure to corrosive salt water. And the payoff, if you could solve those engineering problems, baseload renewable power, 24 hours a day, 365 days a year. The first gift was the one they'd came for. Electricity, baseload power, the kind that doesn't care if the sun is shining or the wind is blowing. The early experimental plants in the 1980s were small, generating only 50, maybe 100 kilowatts. Enough to prove the concept. But the modern designs, they're thinking bigger, much bigger. A single commercial-scale OTEC plant, with the right location, the right depth, could generate 10, 50, even 100 megawatts. Enough to power tens of thousands of homes, continuously. The second gift was desalination. They noticed something about that cold water. When you pump it up from 3,000 feet down and run it through the heat exchange system, condensation forms. Fresh water. The same way a cold glass sweats on a hot day, the OTC system produces fresh water as a natural byproduct of the temperature difference. The early plants produced thousands of gallons a day. Modern designs could scale that to millions. For islands where fresh water is scarce, where every drop has to be collected from rain or pumped from underground aquifers, this changes the equation. You're not choosing between power and water. You're getting both. The third gift is nutrients. Deep ocean water is part of a global circulation system. Over decades, minerals and nutrients from the surface sink down and accumulate. Nitrogen, phosphorus, trace minerals, everything that marine life needs. So when you pump that water up, before you desalinate it, before it becomes fresh water, you can divert some of it directly to aquaculture. Cold, nutrient-rich seawater. Perfect for cold water species. Abalone, cold water fish, even some types of seaweed. Species that would normally need expensive refrigeration and nutrient supplementation, here they're swimming in water that's naturally 39 degrees and already loaded with everything they need to grow. Vertical space isn't just scenery, it's physics. And in Hawaii, physics is the ultimate form of sovereignty. Right now, the Strait of Hormuz, that 21-mile-wide channel between Iran and Oman, is a question mark. Will tankers get through? Will insurance rates spike? Will the route open again soon? On a normal day, 21 million barrels of oil pass through there. 1/5 of the world's petroleum, bound for Japan, or South Korea, or maybe Hawaii. Like Hawaii, Japan and South Korea are vertical nations. They've realized that true security isn't found in a tanker. It's found in the temperature of their own waters. But beyond the engineering, there is a deeper beauty here. It's the beauty of a landscape that provides for its people. The three gifts of OTC, power, water, and food, aren't just industrial byproducts. They are the tools of independence. It means a future where the beauty of the islands isn't just something we protect. It's something that protects us. A future where Hawaii doesn't look to the horizon for the next ship, but looks to the depths for its own strength. The ocean has been waiting for millions of years, and I can't help but wonder what stories the hula dancers of the future will tell about this mountain and the abyss.